our session last. Okay. Regarding the how we're gonna solve Navier-Stokes equations for a flat plate with an inclination. Okay. Last week, we did the Navier-Stokes equations simplification. Okay. So we cancel out certain terms and we left with this one. So 0 equals to rho gx plus mu del squared u over del y squared. Okay. So what we do is we need to convert gx into g, right? Because the actual gravity will be g. Okay. Gx is component of gravity in x direction. For our friends who just joined, please switch on your camera. Right. So next, what we do is we convert this one into g sine theta. So this is how we do the conversion. This is the gx component because of the gravity on x-axis. Okay. Then you have a gravity on y-axis. The actual gravity acting on this is actually in this direction, which is the one that we feel now, right? Directly towards the bottom side. Okay. So from here, we found out that gx is actually g sine theta. Okay. Opposite hypotenuse. Sine of theta 15 degrees C is actually 15 degree is actually theta. So the sine of theta is gx divided by g. So therefore gx equals to g sine theta. Okay. There's no gy component because of the plate is, the fluid flows due to the component of x, not gy. So why we do this one? Because the known value of gravity only g. So g is 9.81, right? So from there you can determine gx. So gx equals to g sine theta. So then what we do is replace gx with that value. So we get this one. Okay, 0 equals to rho g sine theta plus mu del squared u over del y squared. Okay, so our objective once again is to determine the expression of velocity. So in our case, the velocity will be u component only, right? So we need to rearrange this one. So del squared u over del y squared. So everything else we put it to the other side. Okay, so it becomes negative rho g sine theta divided by v. Okay. So obviously what we need to do is we need to integrate. So it becomes del u over del y equals to negative rho g sine theta divided by mu multiplied with y. Okay. Because we integrate towards y. So that's why we have per kali here becomes y. Rho g sin theta divided by mu and y plus a constant. Okay. We put that as C1. So not yet, because we want u, so we need to integrate again, and it becomes this equation. U equals to negative rho g sin theta y squared divided by 2 mu plus C1y plus C2. So, any question? Any question?
Can you explain again at the GX? I cannot understand.
What if I want to explain, I need to know what that exactly that you don't understand.
Uh, must it always be signed?
Sine. How it
Oh,
becomes sine. If you take a look here, okay. Alright. The main rules would be first is G. Okay. G should be in this direction. Right? And another one is Gx and Gy component should be less in terms of magnitude compared to G. Right? So G must become the highest magnitude. So it represents here as the longest line. Okay, longest line. Alright. So cannot be Gy become the hypotenuse. That's the idea would be. And Gx also cannot be become hypotenuse. So it should be G. Right? So now done. Meaning you should know that the actual G should become hypotenuse. Okay. And next what we do is we basically play around with the angle. Right? So you have 15 degree here, and then this one is 75, 70, becomes 75 degree because of 90 degree, right? So since this is um, the one that in horizontal, right? So 90 degree to the horizontal should be the G, the gravity, the actual gravity. Okay. So from 75, it becomes 15 degree once again, which is actually our theta. Okay. So this Gx component, what we do is we transfer this line to this one. Of course, my drawing, right? So this Gx and this one is Gx is actually same. Okay. For example, since you know that Gx and Gy should be less than G, so you cannot basically draw become something like that. Right? So this one become 90 degrees, so it's totally wrong. Okay. So the one that connected 90 degrees should be Gx and Gy, which is exactly follows our rules that we set previously. G should be the largest value. So from there, yeah, this one just play around with trigonometry. Okay, so become sine theta. So this is opposite hypotenuse, right? You all still use the same. Like me, I'm using SOHCAH. TOA.
Yes. We are using the same.
Right?
Okay, thank you, sir.
So not so far different.
Mm.
Your teacher and my teacher. All right. Anything else? So what are the next steps? Okay. The next step will be to determine C1 and C2. Okay. So I put this become equation number 1, and this one become equation number 2. Because later we're gonna use these two equations to determine C1 and C2. Right. So next what we do is we apply boundary conditions. Okay, take a look this one. Okay, boundary conditions. Alright, first thing first, you need to basically realize that um, the velocity profile is not triangle. Okay, we have a curve there. Okay, so this is the curve, and this curve is due to the gravitational effect. Okay, if you notice, like I mentioned previously, when you, I mean, from the previous example, right? Something like this. So, okay, take a look this one. This is not due to, I mean, the fluid flows not due to plate movement, which is I can put it as an external force. It's somebody who actually force the fluid to flow by move the plate. This is due to pressure, okay? Due to pressure difference. So if you have a fluid something like this, meaning the pressure will be there is a difference in pressure. So for this case, meaning this pressure should be lower than this one, right? So for pressure, how we draw it basically is not going to be straight. Once again, we draw it with a curve, with a certain, not straight line. And then another one is like our case here. Okay, now this is not due to pressure. This is due to gravitational effect. Once again, it's gonna be a curve. So I can say that when you apply external force that causes the fluid to flow, that one should be straight line. So that's why become triangle. Okay. What we have here, triangle, straight line. But if naturally occurs pressure or gravitational effect, so you need to draw it like a curve, right? So that is the first thing that you need to understand. Or okay. So next, what we after that, then you can apply what kind of boundary conditions. Okay, and this is true for boundary condition number 2. Okay, so for BC2, the height is actually h, right? So at y equals to h, du over dy equals to 0. Okay. It means something like this. Okay, if I basically continue this drawing, your flow will become something like that. Okay, so it's gonna have an arrow which is similar magnitude. So meaning at this point, right, the change of u towards y becomes 0. Okay, because if we analyze it, continue to the top, so what happen is there's no change. Okay, so that's why du over dy equals to 0. Okay, rather than this curve, there is a change of u towards y. So that is for BC number. And for BC number 1, it's simple, right? So at y equals to 0, u equals to. Any question on this one? Okay. So next what we do, we apply those boundary conditions. Okay. So at BC number 1, u equals to 0, y equals to 0. Okay. What we have is 0 equals to negative rho g sine theta divided by 2 mu. Multiply with 0, this one is 0, and then we're going to find that C2 equals to 0. Okay, done for C2. Okay, next we apply BC number 2. Okay. So at y equals to h, du over dy equals to 0. So we're going to apply it at this one, at equation number 1. So what you have is this one. So 0, negative rho g sine theta divided by mu h plus C1. So from there we determine C1. So C1 equals to positive rho g sine theta h divided by mu. Okay. So now we know all the unknowns, the value of the unknowns. So from there, we're going to apply it back to the velocity equation. So just replace that one into this equation. So it becomes u equals to negative rho g sine theta divided by 2 mu y squared plus rho g sine theta h divided by mu y. C2 is 0, right? So tak adalah. Okay. And you can simplify this equation by taking out all the terms, which is equal to both left and right. Okay. So rho g sine theta divided by mu. So this one become hy. We put it at the front, positive, minus y squared divided by 2. So everything else we put it at the outside. So that is the expression for the velocity profile for this case. Okay, any question? Okay, so we're done with this obtain expression for the liquid velocity profile, which is u. Okay. Next is they want you to find the volume flow rate. The expression for the volume flow rate. So somebody give me the equation of Q. Q equals to what? Anyone? Q equals to
VA sir. Volume flow rate.
VA.
come again? Q equals to A multiplied with
V. Volume.
Q equals to A multiplied with right
Velocity.
velocity. Okay. So what we need to do is we need to relate this U into our Q, okay, because we want to find Q, right? So it start like this. Q equals to AV. Okay. But our component velocity is U. Okay. So this V meant for maybe, for U, V, and W. But we already know that there's no V, there's no W, only U. So our equation become Q equals to AU, right? So from here, what we need to do is we need to take a look at the direction of discharge, which is Q, right? So we go back to the figure. Right? So this is Q. Q equals to AV, right? So the area of interest is this one. This is the area. Okay? So meaning, if you notice, the width given is B, right? The width given is B. So this is the width, and this is the B. Okay? So the area will be B multiplied with what? What will be the area? B multiplied with
H.
H. Yes, correct. So B multiplied with H. Okay. So the area is actually we need to analyze in terms of differential, right? So Q equals to from 0 to H. So not directly H, right? From 0 to H, U multiply with dA, the change of area. So what happened to dA? dA is actually B multiplied with the change of Y. Because Y is governed by this one, the change of Y. But B is you have the actual value for B, which is for at the moment we put it as B, right? So it becomes 0 to H U B dy. So B multiplied with dy is actually the area. So next what we do is this B we put it kita keluarkan dia lah. Okay, we take it out. So from 0 to H U dy. So since you already found your U, you put it in this equation. So U is the one that you determined previously. So equals to B from 0 to H rho G sine theta divided by mu. So the U is, this one is U, right? So Hy minus Y squared divided by 2 and dy. So this term, we can take it out as well. So it becomes rho g sine theta b divided by mu. Okay. So the one that we later gonna integrate is only this term, okay, which is hy minus y squared divided by 2. Because of, yeah, they have y in the equation. Okay, so do now. This one, integrate this. So I'll give you a minute or two. Okay, can I ask somebody? Um, Now file.
Yes, sir.
Alright. Give me the results of this integration.
Hy square over 2 minus y cube over 3. Right, y cube over 6.
Alright. Very good now. Okay. So you're gonna have this one. Hy squared divided by 2 minus y cubed divided by 6. So later you're gonna need to put from 0 to h. So do it now. Solve for h and 0 as well. Okay. Nurul Anis.
Yes, sir.
Give me the answer only.
Check. Uh, 2h over 2 minus h2 over 6.
Come again.
2h squared over 2 minus h3 over 6.
2h squared over 2 minus h3 over 6. This h, we put it here, right? So become what?
h h dot h squared
So become h.
dot h squared.
H multiply with h squared become h.
Uh, h over 4
H multiply with h squared. So become,
h cube.
yeah, very good. H cube. Right? Very good. So it's going to become h cube divided by 2 minus h cube divided by 6. Right? And then after you solve for h minus 0, right? Because just put 0. So solve for this one. I mean simplify this one. Okay, Razif Putra. Where is Razif Putra? Are you not there? Razif Putra? Okay. Tuan Aiman. Where is Tuan Aiman? Okay. Muhammad Muizzuddin.
Yes, sir.
How about this one? The result of this?
The result one apa ni? H cube over 3.
H cube over
3.
3. Um, okay. Muhammad Muizzuddin. Thank you.
Okay, sir.
Any other answer?
I got the same answer.
H over 3.
H cube.
H cube over 3.
H cube over 3. Yeah. Right? So, maybe I tak dengar sebelum ni. So, mistakenly here your result. So, this one at the bottom should be 12. 6 minus 2, 4 divided by 12, so become H cube over 3. Right, sorry. Right? So, 4H cube divided by 12, so later it's going to become...
It's 9 hours.
Rho G sine theta B H cube divided by B mu. Alright, good. Thank you. Okay, so that will be the answer, which is the expression of Q that they want. Okay, so this one later. Do not put yet.
Nilai B tu tak tahu eh.
Okay, they want expression actually. Good question, right? If you put B here, your equation become rho G sine theta H cube divided by 3 mu, right? Because based on the equation, B is 1 meter wide. Okay, but once again, expression. Right? So if you just directly replace the value, your expression is going to be different. It's going to be perhaps rho G sine theta H cube divided by 3 mu. Okay. Let's say if B become 2, for example. Okay. So it become rho G sine theta 2 H cube divided by 3 mu. So no, okay, we don't want that. We want the expression. Do not replace the value yet. There will be no mark if you get it wrong. Okay. So leave it like that expression. Later we're gonna put the value. Clear?
Clear. Good.
What is code? Come on. Tanya lagi. Because question B is obtain expressions for liquid velocity profile, for the volume flow rate, for the average velocity.
Oh, so the question only want the expressions and not the answer. We don't need to substitute the value, right, sir?
Yes. If you
Okay.
yeah. So for B, if you substitute the value, there will be no mark for that because they want expressions. Okay. Clear?
It's clear.
Okay, this is important.
Yeah, okay.
Really important because normally B, your senior always replace. So in the end, tak ada markah. Rugilah kat situ. Yeah, you correct actually, but you don't get the expression. You only get the final answer. Hampir 60% lah yang buat sebegini. So, yeah, good question. Alright, next is once again expression for the average velocity. So V equals to what? Q divided by A, right? You want V now, or U actually. Okay. Equals to Q divided by A. Right. So you have your equation Q divided by A, so should be U. Rho G sin theta BH cube divided by 3 mu, meaning we put the Q back into this equation. And then area is B multiplied with H. Remember just now? The area. So this is B, this is H. Okay. So for this step, no need for you to put it in terms of dy, for example, because you already determine it through Q. Okay. So just put it B multiplied with H, so you cancel out. B cancel out with B, and H cancel out with H. So this is the expression for the average velocity. Rho G sin theta H squared divided by done for B. Next we go to C. Relate the liquid thickness to the volume flow rate. Okay, per unit depth of surface normal to the flow. Okay, the keyword is what they want is H. Thickness is H, right? H in terms of Q. Relate liquid thickness to the volume flow rate. So yeah, since we already found Q, so we just need to rearrange the equation. That's the Q just now. This one, right? So meaning H and what are the Qs? Okay, so this one is the answer. So just put it to the other side. So you're gonna have 3 mu Q divided by rho G sin theta B 1 over 3. That's it. That is for C. question? Okay, so if all is good, so we go to D. Now D is actually calculate. So this is where you need to determine the actual value. See the difference? B and D. D is calculate, or perhaps they put it as determine the value of something like that, the volume flow rate. B is obtain expressions. D is calculate. So this is where you put all the values into the equation. So they want you to find Q. Okay. So rho is 1000, G is 9.81, theta given is 15 degree, P is 1 meter, H 0.001 because of the thickness H is 1 millimeter and mu given is 1 times 10 to power of negative 3. Right? Calculate? No? Okay. So the answer is 8.46 times 10 to power of negative 4 meter cube per second. Did you got the same?
Yes.
Right? So everybody got the same answer. Okay, that's it. So this question will be what? 20 marks. Okay, this question is for me is quite good and complete. Okay. So they not only ask you the velocity profile, they ask you the volume flow rate, the average velocity, the relation between thickness and volume flow rate. So they're gonna play around with this kind of question. So perhaps instead of relate liquid thickness, they want you to relate average velocity with velocity profile, for example. You just um, follow how we answer this question. And then in the end, they ask you to calculate. For this case, they ask you to calculate volume flow rate. Perhaps later they ask you to calculate U, for example, or V, thickness. Okay, another one. Okay, so done for Navier-Stokes equation for Cartesian coordinates. Okay, so I've taught you fluid flow. Okay, we have a fixed plate at the bottom, moving plate at the top, and I taught you boost fixed plate. Okay, And also what happen when you have the same concept but apply it on the vertical. Okay. So there will be a gravitational effect. Okay. So you're gonna have almost similar boundary conditions. For example, this one, 1, 2, and 3. So similar to this one, 1, 2, and 3. And I believe I taught you when the axis positioning, right? When axis is positioned at the center, when the axis is positioned at the bottom. Okay. So how you, the value for boundary conditions will be different, totally different when your axis positioning is different. And also you learn on when this one is changed. Okay. Normally my example would be X and Y. Okay. But it's not gonna be like that, for example. Okay. Perhaps they change it into this one become Z, this one become X. So the component velocity will be different. The value would be W because of direction is Z, and dW changes with dx, right? Right, so complete. So that are the Navier-Stokes equation for Cartesian coordinates. And just now I taught you on, you've learned on when you have a fluid flow when plate is in inclination with an angle. Okay, so perhaps we go for a rest. We take a break. So we meet again at 9:20, and we continue with Navier-Stokes equation for cylindrical coordinates. So see you again later. So next, what we're gonna do is okay. We're gonna analyze Navier-Stokes equation for cylindrical coordinates. Okay. So for Cartesian coordinates is x, y, and z, right? Okay, this is x, this is y, this one is z. But for cylindrical coordinates is when you deal with cylinder. Okay, you have the z direction and you have r, which is the radius, and then you have the theta direction, which is the direction will be rotational. Okay, all right, so let's do this one as the practice for Navier-Stokes equation for cylindrical coordinates. All right, how we solve this one? It's going to be the same like what we did previously for Cartesian coordinates. Okay, you have a Newtonian fluid flows in an annular space created by concentric pipe of radius r outer. Okay, this one I want to explain about annular space. What it means by annular space is you have two cylinders, one hollow, another one is not hollow. Okay, so this is where your fluid. Okay, so between cylinder 1 to cylinder 2, okay, you have the fluid. So this is what we call as a annular space. So for this case, it looks something like this, right? So this is where the fluid position. The space is created by a concentric pipe of radius r outer and a rod of radius r inner. Okay, this one is rod, this one is pipe. Okay. As shown in figure Q1b, right? Okay, if you want to follow this kind of lecture, just follow step by step what I'm saying and what I show. Do not yet again see all the other things. If not, you're gonna get confused and gonna be left out. Okay. Okay, the rod is moving at a constant velocity v. Okay, this is the rod. Inside this one is actually the rod. It moves at a constant velocity v. Right? So it move in, we assume it move to the right only. Okay, so we're gonna analyze at that instance. While pipe is stationary, pipe is fixed. So the flow is steady, laminar, and incompressible, and there is no force pressure gradient driving the flow. Okay. So basically, these are the assumptions. Assuming the velocity components in the radial and tangential directions are zero. Okay. So the question is quite baik hati kalau ikutkan. Alright. They mention about what happened to the velocity component in the radial and tangential direction, which is theta direction. Both are zero. Okay. And ignoring the effects of gravity. Okay. Once again, they told you about what happened to the gravity. Derive an expression for the velocity field in the annular space. Right? So take a look here. So this is your z-axis, and this one is actually r-axis. Okay. So v moving to the right. So your component velocity would be vz, right? So for rz and theta, you're not going to use uv and w. You're going to use r, vr, theta, v theta, z, vz. Okay. So like before, we already determined vz as our component velocity. Okay, but tell me, vz changes with what? Del vz change with t what? Anyone?
dw.
You don't have w here. You only have r, z, and theta.
d.
No. Say lagi. Remember before we have a fluid flow, something like this. Okay. So this is the x direction. So meaning your velocity is actually u. Okay, this one is y direction. So the change of u towards what? Towards y, right? It's not equals to 0. 0, 2, 4, 8. So meaning u changes with y because this is y. So how about this one? Vz changes with what? Yeah, very good.
DR.
Del VZ changes with DR. Okay. So the profile will look similar to a fixed plate and a moving plate. Okay. We analyze it through 2D, right? Because at the bottom, road moving to the right, and top is pipe, which is fixed. So basically, you're gonna have a triangle as your velocity profile. Okay. So you got to see here that the profile is not drawn for you. So you need to determine that. You need to find what is the profile looks like. So make sure you get it right. So del VZ over del R is not equals to 0. Okay, done. Those are the three things that we need to find first. The profile, the component velocity involved, VZ, and what are the changes? What is the change towards what direction? Okay, assumptions. How many assumptions before this we have?
4.
4. Number 1 should be
Steady flow.
Steady flow.
steady flow. Always like that. Okay, number 2.
No flow in Y direction. In R direction.
Yes. Right before, after you determine the component velocity, you put number 2 as a no flow in a certain direction. So for this case, like mentioned by your friends, is actually he chose no flow in R direction. So meaning VR equals to 0, right? VR equals to 0. No flow in R direction, VR equals to 0. Okay, number 3. Anyone? Number 3?
Fully developed laminar flow.
Yes, fully developed laminar flow. So mathematically, del Vz over
DR.
no. Remember this one? You have U, component velocity, and the profile. Look, you should mind my drawing. This
DZ.
Del
del,
VZ over del
DZ.
Z.
del Vz over del.
Z.
Yeah, very good.
Z.
Yeah, del Vz over del Z does not change. The triangle will always look the same at any position because you already assume fully developed laminar flow. Del Vz over del Z equals to 0. Okay. The profile the same like this one. Assume the same, sama. So meaning del U over del X, the change of U towards X is equals to 0. There is no change. So for this case, del Vz over del Z equals to 0. Okay, number 4. No flow in
Theta direction.
theta direction, meaning V,
Theta equals to 0.
yeah, V theta equals to. Okay. So accompanied to the number 2 and number 4 must be accompanied by this one, del over del R or del over del theta. Del over del R cannot be equals to 0 because you already established that it cannot be equals to 0. Del over del theta, yes, equals to 0. So if you notice, we have 4 assumptions almost similar to Cartesian coordinates that you've learned before. Okay, what are the next steps we need to solve for?
BC, boundary condition.
Not yet.
Continuity equation.
Yes, we need to solve for continuity equation. Okay. The appendix is given. Right? Appendices is given. So this is continuity equation for cylindrical coordinates. Okay. VR 0, right? P theta also 0. So number 2 and number 4. So we cancel out that one. So we left with del Vz over del Z equals to 0. So that's how we solve for continuity equation. And also we found that del Vz over del Z, it is 0 due to fully developed laminar flow. So meaning 0 equals to 0, we satisfy continuity equation. Okay? Alright. Next we go to Navier-Stokes equation. Okay. Somebody tell me. First, what we can cancel? We have three components, R, theta, and Z. Which one that I can cancel?
Theta.
The whole theta, right?
Yes.
And then this is number 4. Can I cancel out this one?
Yes, sir.
Number what?
2.
Number 2. Okay, done. Next, we go to Z component. This one we cannot cancel because our component velocity is Vz. Okay. Right. So take a look at the first term. Del Vz over del T. I can cancel or not? Muhammad Irfan. Irfan.
Yes, sir.
Del Vz over del T. Can I cancel?
Del UZ dah over DT eh.
Yes.
Z cancel
Why?
cause steady flow.
Yes, very good. Steady flow. Number 1, right?
Number 1, yes.
Okay, next. Putri Dania. What happened to the second term?
Second term, cancel
Which one?
because number 2, no flow
Number,
in our direction.
there's no flow in R direction.
Direction.
We are 0, right?
Yeah.
So number 2. How about del Vz over del R?
Automatically cancel.
Yes. Automatically cancel due to VR. Okay. Thank you.
Yes.
Okay, next is Ikmal, Naim. Ikmal.
Yes, sir.
Yes. How about this next term?
Uh, cancel. Cancel, sir.
Because of?
U theta is 0.
V
Number
theta.
4. No
Yes.
flow in theta direction.
Yes. V theta is 0, right? Number 4. Del Vz over del theta?
Cancel also lah. Dah kali dengan tu.
Okay. Del Vz over del theta. We have number 4 also, right? This one?
Yes. Yes, yes.
Kan? Number 4 also, right? So basically both can be cancelled out. Okay. The reason I do this because I want you to analyze each term of it and then you know which one you cancel, not just simply cancel. Thank you, Ikmal.
Welcome, sir.
Am I correct? This one, del VZ over del theta is number 4. Number 4 kan?
Yes, yes.
Okay. This one is VZ should be there, and then del VZ over del Z cancel out due to number what?
3.
Fully developed laminar flow. Right? So done. Okay, next we go to the pressure gradient. Can I cancel or not? Muhammad Izra.
Yes, sir.
Muhammad Izra. Can I cancel del P over del Z?
No.
Take a look in detail.
Yes. No one force pressure gradient.
Yeah. So we can cancel, right?
Yeah, yes.
Alright. Thank you, Muhammad Izra. Okay, but the thing is, this is a closed system. In actual, there will be a pressure gradient. Okay. Semua faham eh? In actual, there will be a pressure gradient. But because of the question itself, ignore that. So we cancel. So who you
So it can be cancelled if it was detection lah.
Yeah. If it is stated in the question, there is no force pressure gradient, meaning cancel. You can cancel. But if no statement at all regarding that about pressure can be cancelled out, so meaning pressure should be there because this is a closed system. Okay. So del P over del Z cancel. Rho GZ cancel, right? Because there's no gravitational effect. Also mentioned in the question. Ignore the effects of gravity. Okay. Next, we analyze the sharing term. So how we're gonna analyze sharing term is take a look. Do not take a look of 1 over r. There are 1 over r squared. No. The one that we need to analyze is del Vz. Okay, del Vz over del r, del Vz over del theta, del Vz over del z. Okay. So number 1, Muhammad Najmi Muhammad. I got 2 Najmi here. Or 3 Najmi.
3.
Which one? Muhammad Najmi Muhammad, is it?
Yes, sir.
Yeah. Right.
Ah,
How about the first term? Can I cancel or not?
can, sir.
Because of number.
Because no flow in other direction.
Check again. Muhammad
Check
Najmi.
again.
Yes. Can I cancel or not?
Cannot, sir.
Cannot, right?
Yeah, cannot.
Because VZ changes with R, right?
Yes.
So we cannot cancel. Right, thank you. So this term cannot be cancelled out. Okay, next is del VZ over del theta. Muhammad Najmi Hakim. Pula. Hakim kan? Muhammad Najmi.
Cannot, sir.
Can I cancel or not?
Cannot.
Check again. The 4 assumptions.
Can sir, can. But
We
overflow.
need to answer, right? Which one? Number 2 or number 4? Number 2 or number 4? Sorry.
4.
Number 4. Okay, alright. So number 4. This one cancel. This is number 4. Del Vz over del Z squared. Yeah, we cancel because of number 3. Okay, so we left out with only this equation. Mu 1 over R del over del R del Vz over del R. Okay. Any question on this simplification? How we simplified the Navier-Stokes? Okay. Right, similar to this one. So your equation will become this mu 1 over R del over del R del Vz over del R equals to 0. Okay. So other than that, you already cancel out. Okay. Okay. Next, what we do is mu can be cancelled out. We just put it there, cancel out, and even 1 over R also we put it there. I mean, we put it to the other side, so cancel out. So in the end, you left with del over del R del Vz over del R equals to 0. So the same approach, we integrate. Okay, our objective is Vz. So we integrate del over del R. This cancel out each other. So it become R del Vz over del R. Okay, 0 integrate become C1. Okay. So this R, I transfer it there to the other side. So become C1 divided by R. Okay. We take a moment if you want to salin. Okay. So integration of 1 over R become what? What is the integration of C1 over R? You guys remember? Calculus?
Lon
Lon?
C1.
Yeah, C1 ln. Yes, ln R. Thank you, Adiba. So it becomes Vz equals to C1 ln R. Okay. And then plus C2. Okay, so next we're going to apply boundary conditions BC1 and BC2. Okay, so we take a look at this residue profile. So BC1 I put at the top, BC2 at the bottom. Okay, The radius is R inner and R outer, starting from the centroid or center line to the first root thickness is R inner, to the pipe thickness is the thickness. I mean the height line. So it's actually R outer. So for BC1 at R, so this is R direction, at R equals to R outer, VZ equals to 0, right? There's no velocity there. Okay, that is BC number 1. And for BC number 2, at R equals to R inner, VZ equals to V. Okay, because of this one. The velocity given is actually V. Do not put it as VZ. I mean VZ equals to VZ. Wrong. Because already been stated here that VZ equals to, I mean the velocity is actually V. So you should put as VZ equals to. So those are the boundary conditions. So next what you're going to do is you're going to apply the boundary condition to the equation. So BC1, 0 just now, equals to VZ equals to 0 equals to C1 ln R0 plus C2. So that is BC number 1. And BC number 2, VZ equal to VZ equal to V and R equals to R inner. So you use the same equation. VZ equals to V and R equals to R inner. Okay, so you have C1 ln R inner plus C2. Okay, so here you have two equations and two unknowns. So basically you can solve this problem, right? So let's solve for C1 first. So meaning we need to find C2, okay, from this equation. So C2 is gonna become negative C1 ln R0. Okay. So this term, we put it in this equation. Sorry, this one, C2. So V equals to C1 ln R inner minus C1 ln R0. So you simplify this one, equals to C1 ln R inner minus ln R outer. Sorry, outer. Okay. So our objective is to find C1. So meaning C1 equals to V divided by ln R inner divided by R outer. Because when you have minus, it's actually ln R inner divided by R outer. Okay, so that is the answer for C1. Okay, the answer is correct. Nothing wrong with it. Okay, totally correct. Correct. But the thing is, normally, I mean, as we get lots of experience, and after maybe when you read through the books, normally they will rearrange R outer at the top, R inner at the bottom because of yeah, that's how it is. Due to the radius is larger, okay. So we want to have not 0 point something. It's actually become nombor bulat lah. Okay, for now. So what becomes your equation is this one. So when you rearrange this one, ln R outer divided by R inner, basically you terbalikkan yang ni lah. So it's gonna become negative. C1 equals to negative V divided by ln R outer divided by R inner. Okay. So in this case, I'm gonna use this one. But if you want to use this, tak salah. Will be never wrong. Itu je. No problem. Okay. So I'm gonna continue use this one. So C1 equals to negative V ln R outer divided by R inner. So what I do is I put it back into this equation. Why? Because now I want to find C2. Okay. So C1, put it here, and you will determine this one. C2 negative, C1 also negative just now. V divided by ln R outer divided by R inner multiplied with ln R outer. So finally your C2 is V ln R outer. This one multiplied with this one divided by ln R outer divided by R inner. So that is your C2. Okay. I'm going to take a moment for you to write down. Right. So next what we do is you're gonna put it this one Vz equals to C1 ln R plus C2. Okay. Alright. Masukkan and try to simplify. Okay. So I just leave it there. So yeah, maybe next class I'm gonna give you the answer. Put it in the equation. In this equation number 1 and try to simplify how it looks like. Okay, so there you go. So that is for chapter 2. So for next class, we're going to continue with the next chapter. I'm sorry, this is chapter 1. So for next class, we're going to continue with chapter number 2. So any question on this chapter?
Sir,
Yes.
calculation Sir ni Sir akan upload kat mana-mana ke?
No.
Okay.
I do have classes which totally I record. So yeah, for chapter 1, this is my method of teaching. Okay. So I'm gonna mix up the how I teach you guys. Some chapter or some subchapter I record it. So yeah, so you can have the benefits of both kind of teaching. One recorded, another one is totally face to face with me. So hopefully, yeah, you can have both style of teaching or lesson. Alright, for tutorials, so my method is something like this. I'm gonna teach you, and then you try. And my example is actually, as you can see, it's actually a question, not an example. It's actually a question. So that become my example. So more or less is quite a tutorial for you guys as well. But I'm gonna continue with chapter 2, and then after completed chapter 2, before your exam, I think we're gonna have time for tutorials. Okay, so yeah, you're gonna concentrate on it because those tutorials are quite near to your exam, right? So I should expect those kind of things in your lesson. Hopefully, okay, like that.
Okay.
Yes, sir.
Yes. Okay, you can fill in your attendance.
It hours.
Okay, while waiting for your friends, fill up the attendance. Any question at all on this chapter?
Sir,
Yes.
tanya sikit untuk C1.
Yep.
Ada final answer sir tu for the lawn and lawn are inner over R outer kan. After that jadi negatif. Macam mana tu sir? Ya, lepas tu dia tukar. Macam mana? Sebab apa?
This one is the answer, right? So
Ya,
C1
ya.
C1 equals to V divided by ln R inner divided by R outer, right? Okay, like I mentioned, normally we or engineers always put R outer at the top and R inner at the bottom because of we want to have nombor bulat, or perhaps yalah perangai engineer. Okay, so when what happen is when you put it something like this, you terbalikkan, this one become negative, right? Sama macam ni lah, the same concept. Kalau saya terbalikkan this one another negative kat situ. Okay, so that's why become negative. Are you clear?
Okay sir, clear sir. So tak ada problem lah kalau stay dengan yang atas tu pun kan?
Yeah, no, not really a problem. Tak ada masalah. If you want to stay like this also can.
Okay sir, thank you sir.
Both are correct. Okay, 27 students. Ada lagi ni. Siapa lagi yang tak isi? Okay, cepat isi. Alright, so thank you. So before we end our class, we recite for tasbih kepada Sarawak.
Thank you, sir.
Alright, thank you, and see you
Thank
next
you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.